I gotta say, I'm pretty excited. It's really exhausting teaching Bell to Bell. I gotta tell you, pre-op is way easier. Teach 15 minutes and then just basically chill for 45 minutes. Oh. All right.
Can we go outside and play?
That's exactly what the pre-algebra kids say.
Diagram.
Same mentality, obviously. Okay. The answer is no, we cannot. But we will watch cartoons. How's that? All right. Here we go. So, first of all, I think you will all agree that I have a kind of weaselly voice, and it's not the booming, manly voice of Mr. McKellar's. Would you agree?
Absolutely.
Absolutely. So darling. Okay. So this is also not a physics class, as you can agree. So I will beg you, as we go through this lesson, recall it's not physics, and I am constantly going to be saying, develop the equation for velocity and height. Not recall from physics the equation for velocity and height. Develop via calculus. The equations that you memorized, they come from calculus. You're going to show that. All right. So here we go. The idea is you're starting, if you can move in a lot of ways. Okay, so there's tons of motion problems. You know, if cars moving, accelerating, or all that stuff, that's not motion due to gravity. So this is a subset of motion, of a huge field of motion problems. Motion problems where you have gravity, so your component is starting. All right? Now, when something's moving vertically, then it could be affected by two things. Gravity, obviously, but also that which I give it. You know, its initial velocity that I use to propel. There'll be two, then, components to this. This is the process. You'll always start from what you absolutely know, which is gravity, acceleration due to gravity. I wish I would have put this in a box over here, but would you put over here in a box that acceleration due to gravity at sea level on Earth is negative 9.8 meters per second, which I'm sure you all know, but you might not know negative 32 feet per second.
Always in meters.
What?
Always in meters.
In the book, you'll sometimes see feet. I know you probably never touch feet ever in physics, but in the book, you're going to get some feet sometimes. Okay? The good news is that 32 is a little cleaner number to work with than the metric. Right. I agree. It's terrible. It's terrible. All right. So I took a stab at this and say Devlin is 15 meters high. What do you think? That's probably ballpark. Sure. All right. So say a person at the top of the building. Now, I'm not saying he's dropping it from 15 meters plus his height. Let's just assume he's dropping it right at the top of the building. You with me? So she drops the ball from the 15-meter mark. The question is, how long does it take to hit the ground? Ballpark. What do you think? You can't be wrong. I have no idea.
7 seconds.
7 seconds. Okay, that seems like a long time for 15 meters. We'll see.
I said yes.
I just told you. I hope you can't be wrong. But yeah, you're wrong. Sorry, that's just what you think. Wow. You'll see actually how 7 seconds is a long time. That would be really, really high. You'll see. Okay, we'll see though. We should actually, we are going to ignore friction and resistance due to air friction, or what is it called?
Air
Air resistance. That's right. Air resistance.
Basically, we threw furniture off the roof. Some of it took a while to get there.
You threw furniture? Really?
We did.
You threw furniture?
Yeah.
Why did you do that?
We
And
had-
why wasn't I
We
there?
had to clean.
Throw it away.
Mr.
Cool.
Murphy was on the ground below.
He was in.
Wow. A lot of air resistance to a couch, I imagine. All right. So it's question is how long does it take to hit the ground, but it specifically says not recall the equations for velocity and height from physics. It says develop the equations from acceleration due to gravity. When I go to grade these, it's tedious, and I get tired of counting off -1, -1, -1 on the homework over and over and over again. I count for 8 things of work, 8 steps of work. I should see 8, at least, actually. when you develop velocity, I should see the calculus relationship of velocity to acceleration. What is the velocity-acceleration relationship? Actually, you could look at it two ways, I suppose. Velocity is the blank of acceleration. The antiderivative or integral of acceleration, or I guess you could also say acceleration is the derivative of velocity. But we're going to integrate acceleration. I don't care if you just write that, or if you also show the number going in. I don't need both of those, just one of them. I then need to see the antiderivative. What is the antiderivative of negative 9.8, a constant with respect to time? That's like negative 9.8 t to the 0, which if you raise it by a power, it becomes t to the 1. Wow, that was really challenging or too easy for you? Was that?
Waste our time.
Oh.
Simple questions.
Okay, now in physics you would probably then throw after that initial velocity. Not in calculus, you will not. You will call that the constant of integration. Okay, that's good calculus. Yes.
Sorry, do we have to put the integral in the negative 9.8?
No, one or the other.
In different spots.
This and this, or could you just continue on?
Yeah.
I suppose that's what. All right. Now, in order to find that constant of integration, you'll need an initial condition. What is an initial velocity and time that we can put in to leave us with just C1? T equals 0, velocity is 0. Why do you know that? It doesn't say that in there. Yeah, it starts at rest. Drop is the key word. The initial condition, make sure you read carefully. If it says thrown up, you're using a positive velocity. If you're throwing it down, it's a negative velocity. And if it's simply dropped, then it's starting with no velocity. So, you're implying that the drop derivative, or the velocity, is 0, which means your velocity equation is negative 9.8 t plus nothing, plus negative 9.8 t, period. Okay? I require that you show me using the initial condition, even if you know, oh, it's 0, and I'm not going to get a constant. I don't care. You will show it. Okay? That, then, is complete. 1, 2, 3, 4. Now, let's do the same thing with height. What's the height relationship to velocity? The integral or the antiderivative of velocity, or the antiderivative of negative 9.8 t with respect to time. What is the antiderivative of negative 9.8 t? What's negative 9.8 is just a constant, so it stays up front. What's the derivative of t? 1/2 t squared. Now, if you combine that negative 9.8 and the 1/2 t squared, that'll become negative 4.9 t squared. Okay. We also get a new constant O integration. Do you agree? All right. Do you have an initial height to use to find it? What is it? At time equals 0, the height is 15. 15 equals 0 plus C2, which tells me C2 is 0. So now my height equation is complete. Height is negative 4.9 t squared plus 15. Again, 1, 2, 3, 4. The integral, the antiderivative, the initial condition, and your answer. All right. Finally, we can answer the question here. It says, how long does it take for the ball to hit the ground? If it hits the ground, what is implied? The height is 0. So if I set the height equation equal to 0, it confounds me when people say, can I use my calculator? I don't see why that would be necessary. What is the solution? The square root of? It would be about the square root of 3, yeah, but exactly what is it? 15 over 4.9. Okay? All right, are you with me? So, why use your calculator? There's no reason. Exactly. There's no reason. because your calculator is more work to get a, that's not as good answer. My answer is perfect. Why pick up your calculator to get a less exact answer when you do more work for it? That makes no sense to me. What is the time frame on this? Units wise? Seconds. You do need time. Okay, are you with me? Yeah, so it's about 1.5. It's probably in
It's
both
like
parts.
1.79.
Yeah, square root of 1 or square root of 3-ish, so 1.79 seconds, yeah. Okay, does that about confirm what the couch took to fall from the school?
I mean, when we broke that window, I took about.
Broke a window? Jeez Louise. I had no idea that theater people are such
On the frame,
vagabonds
like, we
or
threw
vagrants.
a window off the roof and it didn't hit the dumpster. It hit the sidewalk.
Nice. Okay.
Yeah. You have to like
Okay. A ball is thrown straight up, released from 0.5 feet above the ground. The ball reaches a max height of 69 feet at time equal to 2 seconds. I don't actually know if that's... Oh, I do need that. Yeah, I do. I don't think I need that whole thing. Actually, that's okay. Find the equations for velocity and height using calculus. So, let's start with acceleration due to gravity. In this case, am I using negative 9.8 or negative 30?
You're going to convert every instance of
No.
problem.
Oh, you do know what it is. Negative 32 is clean, okay? It's feet. So let's go with velocity as the antiderivative of acceleration or the antiderivative of negative 32, either one or both. What is the antiderivative of negative 32 with respect to negative 32t, and then we pick up a constant. We need an initial condition. What is an initial condition for the velocity? Well, I don't really know, do I? Oh, yeah, I do know. What is an initial condition? Doesn't really say, but it's kind of inferred. Max height. What do we know about max height? If it reaches its max height, the velocity is going from
2 is 0.
yes to negative. So if the max height, that implies velocity at 2 is 0. Do you agree? So from that I get 0 equals negative 32 times 2 plus C1. So C1 must be 64. So my velocity equation is negative 32t plus 64. Now we're ready to move on to the second set of work, which is the height development. Height is the antiderivative of velocity, or the antiderivative of negative 32t plus 64. What's the antiderivative of negative 32t? Negative 16t squared. What's the antiderivative of 64? And a new constant. What is actually there are two height conditions you can use. Give me one. 0, 5, yeah, initial height of 5, or we can also use 269. You'll find they come out the same way, but let's use 0, 5 because it's cleaner. That implies that the height equation is negative 16t squared plus 64t plus 5. Wait. Okay. I guess we're done. Isn't that all we had to do? Huh, we're done. Yay. Okay. Again, please, I understand your physics knowledge is great, and I will use it heavily. But when you integrate, I don't want to see you saying that the antiderivative is that plus the initial, because then students, that starts to bleed into other motion problems like the car problem. That's not necessarily the case. That constant is not always the initial for every motion problem. It is for falling body problems, but not for every problem. And I prefer you just go with the general, what always works,
It's a basketball.
and that's this. Okay? What about basketball?
Falling bodies.
That's what the book calls them, falling body problems. Not motion. Yeah, it's raining. Yeah, I should put that into my soundtrack. It's raining men. Yeah. Okay. So, Wile E. Coyote, this, we gotta watch a little, this is cartoons from this is when cartoons were good. These are back in the day, huh? Just a couple seconds.
No.
Oh, no! I wonder if I'm gonna get flagged by Jeff Cook for this. I didn't know.
It's just
Yeah, I wonder if somebody's on the way here to,
the
rest
FBI is
me.
on their way.
yeah.
Just start from the beginning.
Is there anything I could do to help this? Oh, shut up.
Wait, how did we get here? I don't remember.
Oh, I'm not gonna start it. Start. Come on. It's Wile E. Coyote cartoon girls.
Whoa.
Have you ever seen Wile E. Coyote?
Looks like we're watching porn.
You're an American and you've never seen Wile E. Coyote? Did you live in a home? He's pretty different.
I know this is pretty.
See, here's the line. Look at that. Constant velocity, not true. See that? Look at that. He should be accelerating, yeah?
It's garbage.
It's garbage.
This is
Okay, oh, that's a good part too. Oh, here. Oh, Surgeon General parlors. I like this. Oh, wait, here, this is good part too. This is. Oh, wait.
It's only 7 minutes, like.
No way. Maybe at the end. Well, it said that Surgeon General says that chasing, whatever.
Chasing roadrunners can be detrimental.
Okay. That's for later. Maybe we'll get back to that. Gosh, you guys really should. That should be your homework tonight, to watch a ton of Wile E. You can't really understand velocity and acceleration.
Nice. Put the link on your website. Forget this.
Put a link on. Okay, maybe I will. All right.
the link on his website, but they would just have to watch it all over.
So Wile E. Coyote falls from a cliff. It takes him 7 seconds to hit the ground. How high is the cliff?
Find out.
Shall we go metric or metric? Okay, so let's start with acceleration due to gravity. And which is to say velocity is the antiderivative of negative 9.8 with respect to time. The antiderivative is
15.
plus a constant. Do we have an initial velocity?
This is stupid.
Oh, wow.
I just wrote T instead of DT.
Oh, okay. Wow, my nightmares as a teacher right there. At time 0, his velocity was 0. Falls from a cliff kind of implies that it had no initial component to it. So 0 equals 0 plus c1. Velocity equals negative 9.8 t only, therefore. Now let's go on to the height. Height is the antiderivative of velocity, which is the antiderivative of negative 9.8 t with respect to time. What is the antiderivative of negative 9.8 t? Negative 4.9. Here's homework, by the way. It should be 2 cents and maybe a couple to make sense. Okay. Negative 4.9 t squared plus a new constant. Do we have a new constant? Or do we have a condition with which to find that? What is it? 0 at 7. Height 0 at time 7. Shall we just do that mentally? Can we do negative 4.9 times 49 mentally?
49
These are
squared
calculated.
times 0.1.
Times 0.1. So what is that? Let's see. 16 plus 36, 720, 2320, 23, 2401?
Sure.
240.1, I think. What do you think? C2 is, somebody check me on that, please. I'm doing that mentally. 240.1. Is that, oh, super. Okay. So the height equation is negative 4.9 t squared plus 240.1. That's complete and that's great, but let's answer the question. How high is the cliff? At time 0, the height is 240.1, I guess that meters. That's really tall, it seems like. That's, I suppose, possible. All right, are you with me?
No,
Okay, then. What, are you catching up or you don't
I'm
understand?
not.
Okay. Does anybody not understand? All right, then. That's pretty much the deal. In order to practice this a wee bit, would you go to or get your problem set out and look at number 3. We'll do one off the homework because this is going pretty well, it seems like. In number 3, it says the ball is thrown up with velocity 30 meters per second from a 100-meter tall building. Give me equations for velocity and height and find the max height. Okay, will you try that on your own?
That's
100 meters, yes. Tall building, it says. How we doing? Check your velocity and height equations. With appropriate work. Count 1, 2, 3, 4, 5, 6, 7, 8 steps, I hope. And then how do we find the max height? I guess I shouldn't have put that up there. How do we do max height? We didn't do an example like this. Yeah. Okay, so when I find the 0 of v, is that the max height or is that when the max height? That's when the max height. So the thing reaches its max height at 30 over 9.8. Great, seconds, but what is the max height? How do I find what is the max? Yeah, I personally, I don't know about you, it's up to you how you put that in your calculator, but if I have to put something that ugly in a couple places, I generally calculate it, store it to A or something, and use that. So height at that time A is approximately, I've identified height already, I identified A already, so I think my work should be clear to somebody reading it. I get 145.918 meters. You concur? Or not? Okay. All right, also, first of all, to clarify notes in on my paper that I didn't intend to put there, and also to review yesterday. Number 5 and 6 were inverse trig derivatives. I wrote in the box, I think, show all the work or something like that, but that was how I taught it last year. This year, if it's arcsine and arctangent, which these are, I do not expect you to show all the implicit work. So let's do one together, and I will communicate. Let's do 6 first, it's easier. Go to 6. Y equals arctangent of x over 2, find dy dx. Okay, now, I do not require all that implicit work. I'll ask is that, do you recall the derivative of arctangent of u? Yeah, u squared plus 1 or 1 plus u squared. And then you'd have to take the derivative of the inside if there's a chain rule component, right? So in this case, dy dx is 1 over 1 plus or whatever, squared plus. What is the u? X over 2. Is there a chain rule component to this? Yeah, so what's the derivative of the inside? 1. Okay. So that's enough for that. Try 5 on your own. 5 is y equals the arcsine of x over 3. They want dy dx at 2. Find dy dx at 2. Obviously, use your notes if you need to as a reference for a while, but again, you want to, just like always in math, you want to gradually start to try and get those new memory and look at them less and less. But it is pretty new. Yeah, I'll go slow. How's it going? I'm getting something like 1 over root 5. How about you? All right. All right. Check your work if you do not agree, and if you like to rationalize, fine, but I don't require it. All right. Questions on 64. Let's do the replacement, or at least put up the replacement real quick, and then we'll go over other questions. So in this, I think it was something like problem 17.5. You had a cube. I think that's a cube, or is that a parabola? Here, is that a square or a cube? It's so grainy. Okay. At any rate, I think either way it's growing. So it's a rate in like that and a rate out that looks like this. And it's through 8 at least in part B. All right. So we're talking about that. That's what I think of students as weasels. You are weasels. Is the number of weasels increasing or decreasing at time 4 justified? Is it increasing or decreasing at time 4? Well, time 4 is somewhere, all right. It'll be increasing if, what happens with 2 rates?
If the rate in minus the rate out.
Yeah, so you can either compare rate at 4 versus, in versus out at 4 in an inequality form. Or you could say, what is the combination rate in minus out at 4? Either way, and what's the sign? They're both fine. It's good idea to give evidence, not just say in is greater than out or out is greater than in, but give evidence. Depending on the year, there are AP times where if you don't give evidence, you will not get full credit. For example, if you just refer to the graph, hey, the graph is above there, something like that. Gosh darn it, I just had my keyword. I had some evidence. I can't remember what this totals out, but I believe it was 2.6? 15.6, thank you. The in versus out rate is 15.6, which is greater than 0. So the amount of weasels is increasing. The number is increasing. Or dash, as you guys say. To me, that'll always be. All right. Find the absolute min number of weasels on 0 to 8. I hope you started with absolute min is at endpoint or critical number. That is good math. That is Fermat's theorem. To say that is right and should be done. You should then gather the candidates. The endpoints are times 0 and 8, obviously. No justification for where they're coming from, but the critical numbers you should say where they're coming from. How many critical numbers and where are they? There is but one critical number, yeah? Isn't the general critical number where the rate of change is 0? And in this case, what's the rate of change? Or the combined rate of change? Yeah, n minus r equals 0 at time, I think it was 3.119. I'm going by memory now. Yeah, put it back. That would be very much like me. But I guess I could. All right. That'll come up eventually. So, I have 3 candidates, 0, 8, and 3.119. If you rule out the endpoints, I guess you can, but it's not easy to rule out endpoints. You have to say it really well. So I generally, as a rule of thumb, don't. I just find the number of weasels at all cases and compare. So the number of weasels at time 0 is 400. The number of weasels at the endpoint, 8. How do I find the number of weasels given I have rates of change? You integrate with the initial condition. It starts at 400, and the integral represents how much changes by, the amount changes by. From 0 to 8, in minus r, in minus out. And I had, can't remember what after that. Something big, wasn't it?
Just under 700.
700-ish, 700 something. Give 3 decimals, just to be safe, always. The number at 3.119 is 400 plus the integral from 0 to 3.119, n minus r, or out, n minus out. I think that was something like 380 something, or 330 something, 338, I can't remember the name. Yes?
Okay, so if I off to the side wrote that, I used W's and I wrote WT and then my integral, do I still have to show,
I'm listening.
alright, sorry, do I still have to show the integral and say, W8 equals my answer?
I'm really glad you asked that. You do not have to, if you give a general fundamental theorem or integral defined function, and then you just say W at 8 is number, W at 3 is number, you're safe. That's cool. Okay, you can do that. And it's a good time saver. All right. So either which way you look at it, what is the absolute min number of weasels? Yeah. And do they want win or what? They want the absolute min number of weasels or win the absolute min number? What it is. And what is the absolute min number of weasels? 338 weasels. AP problem, they would say round to the nearest weasel or round to the nearest person. Okay. Other questions on the homework? Any other questions on 64? The other class asked about 2, 1, and 14, but that doesn't do it.
Yeah.
Yeah, alpha.
Yeah. Yeah. Okay. 2. Shooby-doo. Okay, so you have a semicircle, and a rectangle is to be inscribed within. This circle has a radius of 3. First of all, let's check your area equation. What's the area equation for the rectangle? Before you do any substituting, what is it? 2xy. Super. How did you get it down to one variable? Or one independent variable? All right. Perfect. Okay, sounds good. So then, that was probably the easy part. The calculus, especially the algebra after the derivative, is the hard part. So let's get through the 2 sticky points. First of all, the product rule and the chain rule combination. Product rule, first stays the same. The derivative on that root expression would be, that's to the 1/2. So 1/2 would come down, it would drop to the negative 1/2, times the derivative of the inside is negative 2x. All right, that's first times the derivative of the second. Plus second is the root, times the derivative of the first is just a 2. Check your product rule and your chain rule. Now let's talk algebra. If I take away a 2 and get a common denominator, what's the common denominator? Square root of 9 minus x squared. The first term's becoming negative 2x squared. And the second one, you get a normal 9 minus x squared times a 2, yeah? So if I set this equal to 0 or undefined and I clean it up a little, I get something like 18 minus 4x squared in the numerator, root 9 minus x squared in the denominator. A prime is 0 if 18 minus 4x squared equals 0, which is that x equal square root of 18 fourths, or the square root of 9 halves, or 3 over root 2. Oui. A prime is undefined if the denominator is 0, which is at x equals 3, but that's obviously a min, because if x equals 3, then it's going all the way out to the edge. That's not much area there. That's not max area. That's min area. So that's bogus. All right. You will find that this is a max. So if you went less than this, then the top would be 18 minus a small number, so positive before that, and after 18 minus a big number, so negative after that. So it is a max, positive to negative. So let's answer the question. I think they asked for the dimensions, not the area. The base is 2x, which is 2 times 3 over root 2. The height is a bit more of a mess. The height is y, which is 9 minus x squared, which in this case would be 9 minus 3 over root 2 squared. That's 9 minus 9 halves, which is 9 halves. Square root of that is 3 over root 2. So there's your base and height. Okay. Question 1. Did you get your revenue? First of all, check this. Do you have your revenue equation? What's revenue? Was it? Price times number. Perfect. All right. We typically then find a price number relationship to substitute in. Did you get your price number equation? What is your price number equation, or is that the part that we get stuck in? I don't want to make this just, oh, you do it for me, Mr. Rickman, and I'll write it down, which is total garbage. I know how to do this. I don't need to practice. So if you need this, then tell me what part you need help with. N equals what?
N times P plus Q.
Yes. Perfect. So let's start with M. What'd you get for M? I think they said, let me refresh my number. I think they said when the price is 16, the number is 4,000. And if they up the price by $1, you lose 100 sales. That statement really is the slope. So what's the slope? Negative 100 over 1, yeah? Okay, so perfect. You got the slope. You could use point slope or just use either point to find the B. If you plug in the first case, you get something like 4,000 equals negative 1,600 plus B. So B is 5,600 plus B. So check your equation. You should have, hopefully, number equals negative 100P plus 5,600. Wait. If you throw that in for number, then you get negative 100P squared plus 5,600P. After that, most people are rolling because you can easily find where R prime goes positive to negative. The derivative is easy, the algebra is easy. You should be rolling. Okay? 14. Find the area of the first quadrant by. Okay, now, I am sure, I have no doubt, knowing me, that I said no calculator. And just to clarify, when I say no calculator, I mean no calculator. No calculator. Any students that go, oh, you mean I can look at the graph? No, you can't look at the graph. You can't use it to integrate. Nothing. No calculator, ever. Period. Okay? You need to practice, what does this look like? Where's the region? That's a skill too. You need to know it. So if it's first quadrant, and it's enclosing itself in the first quadrant, I should find where this is 0. Where does the section get closed? At what axis? What would make that 0? 0 and plus or minus 2. Now, thankfully, they don't make me find both regions. It's just the first quadrant region, I believe. First quadrant region. So they're actually telling you it's up here. I can put in an X between to verify that. But it's definitely like that. This graph, by the way, is kind of the quasi-sine function. It looks like this. The only difference is it's not continuous. Its domain is from -2 too. Or it's not overall real. So, boom, I've got it. Now I can set up my integral from 0 to 2 to x root 4 minus x squared. That is calling for u sub. What's u? 4 minus x squared. Du is negative 2x dx, which is pretty close to what I have. I just don't have that negative. So I'm going to say, well, I have 2x dx. The negative will have to be attached to that du. So that when I go to substitute, I'll get root u and negative du. When you do a definite integral, you also have to, not some suggestion, you will change those. So this is an x value. When x is 0, u would be 4 minus 0, or 4. When x is that upper limit of 2, u is 4 minus 2 squared, or 0. So this becomes from 4 to 0, which kooks me out to see greater to lesser, but I could switch those, call it negative, but that cancels out that negative. So that whole thing is the same as this. integrate 2/3 u to the 3 halves from 0 to 4. And you are on your happy way. Oh, they didn't ask you to find it. Ah, that's a shame. 24 was on the verge of being a great problem, but they stopped short. It's too bad. I don't know. I look myself for a test or something. That'd be cool. Okay. Any other questions on 64? Cool. Time to do work. Time to do homework.